How are you students? Fine. Okay. I am J.K. Kumbar, supervisor in K.A. Bantiya Madhyamik Vidyalaya Navin Panvel, maths teacher. In previous period, we have completed already the syllabus of Maths 1. Last chapter was probability. Today we are going to see Maths-2, chapter 5, coordinate geometry. You know the meaning of coordinate. You know in graph lesson or in linear equation in two variables, a coordinate on x-axis, coordinate in y-axis, or coordinates of points which are any quadrant. Related to this point here, first one is to find the distance between any 2 points on x and y-axis. This is, this is x-axis and this is y-axis. Name of x-axis is x dash, and this will be y dash, and O is the origin, coordinate of origin 0, 0. Here point A and B lies on x-axis. Point A, coordinate of point A is x1, 0, and coordinate of point B is x2, 0. That means coordinate of y-axis on x-axis is 0. If we draw perpendicular on y-axis from A, here is 0, and therefore this is x coordinate, this is y coordinate. This is x coordinate, this is y coordinate. Means the rule of coordinate. Y coordinate on x-axis is 0 and x coordinate on y-axis is 0, and therefore coordinate of point A is x1, 0 and x2, 0. Now we have to find the distance between 2 points. These are the 2 points A and B. We have to find the length of segment AB or distance between point A and point B. Here x2 is greater than x1, and therefore distance AB is equal to x2 minus x1. This is the length of segment AB or distance between point A and B. Now here, if points on y-axis, in first case if points on x-axis, and in second case if points are on y-axis. Again this is x dash axis, this is y-axis, this is origin. Take here point P and here point Q which lies on y-axis. Here coordinate of point P is 0, y1. y1 is coordinate of this point, y2 is coordinate of this point, y coordinate, and x coordinate of both point is 0, because if we draw the perpendicular from Q and P on x-axis, it will be 0, and therefore x coordinate is 0 and y coordinate is y1 and y2. Again here y2 is greater than y1, therefore distance PQ. Distance between these 2 points PQ or length of segment PQ is equal to y2 minus y1. Now we are going to see if points which are joining the segment is parallel to x-axis or y-axis. Draw this figure first and write down this. Again same figure. To find distance between draw this figure and write distance AB and distance PQ. To find distance between segment parallel to x and y axis. Parallel to x and y axis. Again there are two cases. Number 1, this is x axis, this is y axis, this is origin O. Again here is point A, x1, 0, point B, x2, 0. Then take parallel points, or if we join this point, this segment is parallel to x-axis. Suppose these are 2 points, point L and M. If we join these 2 points, this segment LM is parallel to x-axis. Draw perpendicular, again perpendicular, means this is 90 degree. Now here, coordinate of point L is x1, y1 and M is x2, y2. x1 coordinate, here x1 coordinate, this is y1 coordinate here and here also. Then if we observe this figure, these 2 segments are perpendicular from point L and M. This means this is 90 degree. That means quadrilateral ABML or LABM is a rectangle. From figure, quadrilateral LABM is rectangle, and therefore opposite sides are congruent in any rectangle. Therefore AB is equal to LM. AB is equal to LM. But distance between point A and B is x2 minus x1. That means this LM is also x2 minus x1. And therefore distance AB is equal to distance LM is also x2 minus x1. That means if segment is parallel to x-axis or points on x-axis, the formula is same for finding the distance between any 2 points if segment is parallel to x-axis. Now what is second case? If segment is parallel to y-axis. Again draw this figure. X dash, y dash. This is 0. Take point on y-axis is R and S. The coordinate of R is 0, y2 and 0, y1. 0, y1 is coordinate of point S and 0, y2 is coordinate of point R. Then take parallel to y-axis. This one point and this one point. If we join this segment is parallel to y-axis. Again draw perpendicular. Again here also perpendicular. The name of point is P, having coordinate x1, y1, and here Q, x1 same coordinate, x2, y2 and x1, y1. Here also this is perpendicular, therefore this is rectangle, and opposite sides of rectangle is equal, and therefore RS is equal to PQ is equal to, here also PRSQ. Is a rectangle, and therefore distance RS is equal to distance PQ is equal to y2 minus y1. That means if points on y-axis or parallel to y-axis, the distance between these 2 points is y2 minus y1, and if points on x-axis or parallel to x-axis, the distance between these 2 points is equal to x2 minus x1. Now on the basis of this concept, we are going to see if the segment is not parallel to any axis. Draw this figure and write down this. And then third possibility. First possibility, if points on x-axis are parallel to x-axis. Second possibility, points on y-axis are parallel to y-axis. And third possibility will be if the segment is not parallel to any axis. How we can find the distance between these 2 points? After this, there is one activity on page number 102. Complete this activity on page number 102. And then our next point is distance formula if the points are not on x or y axis. This is very important. See carefully what is I am doing here. This is x axis. This is y axis. Origin. And take any 2 points. Take any 2 points in first quadrant, and we have to find the distance between point AB or length of segment AB. Here segment AB is not a parallel to x-axis. If segment AB is parallel to x-axis, then you know distance AB is equal to x2 minus x1. If segment AB is parallel to y-axis, then you know distance AB is equal to y2 minus y1. But here this segment is not a parallel to any axis, and that's why we have to find here distance formula. See carefully. Draw perpendicular from this point on x-axis, from this point also. Then again draw perpendicular on y-axis from point A and B. These are also perpendicular. Now join this. And now see here, this is one type of right angle triangle. Take here point C. This is perpendicular because this is also perpendicular. That means this triangle is nothing but right angle triangle. Now we know the distance between point A and C because this segment is parallel to x-axis, and you know if the segment is parallel to x-axis, the distance between these 2 points is x2 minus x1. Then again, BC is parallel to y-axis. If BC is parallel to y-axis, then you know the distance between point B and C is y2 minus y1. But we have to find distance AB. But you know, this is right angle triangle. By Pythagoras theorem, if we know length of these 2 sides, we can easily find distance AB or length of segment AB. Here, in figure, AC is equal to x2 minus x1 and BC is equal to y2 minus y1. Triangle ACB is a right angled triangle. And therefore by Pythagoras we can write AB square is equal to AC square plus BC square. And therefore AB square is equal to AC square plus BC square. Here AC is x2 minus x1. Therefore AB square is equal to x2 minus x1 bracket square. BC is y2 minus y1, that is y2 minus y1 bracket square. By taking square root of both sides, we get AB is equal to, we can't take square root of each bracket because there is plus sign. AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. This is called as distance formula. This is known as distance formula, and this formula is very important for exam and next practice set also. AB is equal to, if we here we find distance AB or length of segment AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. Keep in your mind, draw this figure carefully, write this formula carefully. This is the proof of formula, but in exam only important AB is equal to, or distance formula AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. This is known as distance formula. Okay, write down carefully, and on the basis of this formula we can easily solve practice set 5.1. Open your textbook. There is practice set 5.1. Question number 1. Find distance between each of the following. Find distance between each of the following. First one, A 2 3, B 4 1. We have to find distance AB. Solution. Let x1 y1 is equal to 2 3 and x2 y2 is equal to 4 1. By distance formula, AB is equal to, what is distance formula? AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equal to under root x2 minus x1. Here x2 is 4 minus x1 is 2. 4 minus 2 bracket square. y2 is 1 minus y1 is 3 bracket square is equal to under root 4 minus 2 bracket square plus 1 minus 3 is minus 2 bracket square. Again here AB is equal to under root 4 minus 2 bracket square plus 1 minus 3 is minus 2 bracket square. 2 square is 4 and minus 2 is square is also plus 4, because minus into minus become plus. under root 4 plus 4 is equal to root 8. Distance AB, find the distance between each of the following. We have to find your distance AB, and distance AB is equal to root 8. But we can simplify here. Therefore, AB is equal to 8 means 4 2s are 8. 8 means 4 2s are 8. And root of 4, because 4 is perfect square number, root of 4 is 2. And therefore required answer is equal to AB is equal to 2 root 2 is final and required answer. See, very easy example. Write down carefully. If any problem, you can call me. Then third one, all are same examples. Third one is R0 minus 3. 0 minus 3 and S 0 5 by 2. 0 5 by 2. In short, I can write here x1, y1, x2, y2. By distance formula, RS, distance RS is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equal to under root. See here, x2 is 0 minus x1 is again 0 bracket square plus y2 5 by 2 minus y1 again minus, keep in bracket, then draw this square bracket square is equal to 0 minus 0, 0, 0 square plus 5 by 2 minus becomes, if we open this bracket, minus minus plus 3, 5 by 2 plus 3 bracket square, RS is equal to under root 0 square is 0, no effect on this number, 5 by 2 plus 3 upon 1 bracket square. Take here denominator 1 for our convenience, is equal to under root 5 1s are 5, 2 3s are 6 divided by 2 1s are 2 bracket square, and therefore RS is equal to under root 5 plus 6 11 divided by 2 bracket square. We can take easier square. This square root and square gets cancelled. Square root and square gets cancelled, and therefore RS is equal to 11 by 2 is required answer. RS is equal to 11 by 2. This is very easy example. Now next, fifth example. Here t minus 3 6 and R 9 minus 10. Nine minus 10. Again, this is x1, this is y1, this is x2, and this is y2. Again, same distance formula. Same distance formula. X2 minus x1, 9. Then x1 is minus 3. 9 minus, in bracket minus 3, bracket square, plus y2. y2 is minus 10. y1 is 6, minus 6, bracket square. See again, x2 is 9 and x1 is minus 3, minus in bracket minus 3, bracket square, plus y2 minus 10 and y1 is 6 minus 6, bracket square, is equal to under root. If we open the bracket, then minus minus become plus. 9 plus 3, then minus 10 minus 6, minus 16, bracket square. RS, not RS, TR is equal to TR is equal to 9 plus 3, 12, and square of 12 is 144. 9 plus 3, 12, square of 12 is 144, minus 16, square of minus 16, square of 16, 16 into 16 means square of 16. 256 is equal to TR under root 400, and root of 400 is 20. This is distance between point T and R, that is TR is equal to 20, is required answer. Again, see, this is very easy example. Then we are going to see how to solve question number 2. Determine whether the points are collinear. Question number 2. Question number 1 is depends on only find the distance, but second and third question is also depends on distance formula. Question number 2, determine whether the points are collinear. Determine whether points are collinear. You know when points are collinear or not. Here first one, A 1 minus 3, B 2 minus 5, and C minus 4 7. And we have to check point A, B, C are collinear or not. How we can check these points are collinear or not? Suppose you know this concept. Suppose this is point A, this is point B, and this is point C. If AB plus BC is equal to AC, then and then only point A, B, C are collinear points. That means we have to find first distance AB, distance BC, and distance AC also. If distance AB is equal to distance AB plus distance BC, then we can write conclusion there, point A, B, C are collinear points. To find first distance AB, and for that purpose this is x1, y1, x2, y2, x3, y3. By distance formula, AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equal to, here x2 is 2 minus x1 is 1, y2 minus 5 minus take here square bracket, x2 minus x1 that is 2 minus 1 bracket square plus y2 minus y1, y2 is negative, minus 5 minus in bracket minus 3 is equal to 2 minus 1 is 1 square plus minus 5 plus 3 bracket square is equal to square of 1 is 1 and then minus 5 plus 3 is minus 2 and square of minus 2 is 4 and therefore AB is equal to under root 5. Minus 5 plus 3 is minus 2 and square of minus 2 is 4 and square of 1 is as it is, 4 plus 1 is 5. Then BC is equal to BC is equal to x3 minus x2 bracket square plus y3 minus y2 bracket square is equal to, now here x3 is minus 4 minus 2 bracket square plus y3 7 y2 minus 5 in bracket minus 5 bracket square is equal to under root minus 4 minus 2, here is addition not a multiplication, minus 2 minus 4 is minus 6 bracket square. After opening the bracket it will be plus 7 plus 5 12 bracket square is equal to square of and square of 12 is 144 is equal to 180. You know, if we factorize the 180, there is one perfect square number. Which one? See here by trial and error method. (36 into 5). 5 6 are 30. Carry on 3. 5 3 are 15 plus 3 is 18. And here 36 is perfect square number and therefore BC is equal to 6 root 5. This is AB root 5, BC 6 root 5. Now we have to find AC. You find AC yourself. AC is equal to under root AC x3 minus x1 bracket square plus y3 minus y1 bracket square. Put the value of x3, x1 and y3, y1. Solve yourself and find distance AC. And now if to satisfy the equation AC is equal to AB plus AC, then you write your final answer. Point A, B, C are collinear. Got it? Find AC yourself. Then if AC is equal to AB plus BC, after putting the value, then if both sides are equal, then you can write their final your answer. Point A, B, C are collinear points. try to complete yourself. And then third question, complete this example yourself. Don't forget this, complete this example yourself. Third one, find the points on the x-axis. Find the point on the x-axis which is equidistant means same distance from a minus 3 4 and b 1 minus 4. Find the points on the x-axis which is equidistant from point A minus 3 4 and B 1 minus 4. What we have to find here? The coordinates on x-axis. Where is this point? The point is on x-axis and that particular point is equidistant from these 2 points. And we have to find the coordinate of point which lies on x-axis. What is the meaning of this example? The point lies on x-axis and these 2 points are equidistant from point which is lies on x-axis, and we have to find the coordinate of point which is on x-axis. Let point, suppose that point will be P. Let point P x0 is on x-axis. This is x coordinate and this is y coordinate. You know the y coordinate on any point on x-axis is 0 and this point is already on the x-axis, and therefore x coordinate is x and y coordinate on x-axis is 0, and therefore let the point P x0 is on x-axis be equidistant from A minus 3 and B 1 minus 4. We know from given condition PA is equal to PB. PA is equal to PB. Squaring both sides, PA square is equal to PB square. And now by distance formula we are putting the value of both sides. X minus minus 3, this is x. X2 minus x1, x2 minus x1, x minus again minus 3. Bracket square plus y2 minus y1, 0 minus 4. Bracket square is equal to under root. X minus 1 bracket square plus 0 minus minus 4. 0 minus minus 4. Therefore, x minus become minus minus become plus 3. Therefore, x plus 3 bracket square plus 0 minus 4 is minus 4 bracket square is equal to x minus 1 bracket square 0 plus 4 bracket square is equal to x plus 3 bracket square. You know this expansion formula. You know a plus b bracket square is equal to a square plus 2ab plus b square. With the help of this formula, we can expand this bracket x plus 3 bracket square. X square, I write here, x plus 3 bracket square, a square plus 2ab means x square plus 3 2s are 6x plus 9. Square of minus 4 is 16 plus 16 is equal to again under root. Here x minus 1 bracket square, x square minus 2x plus 1 and square of 4 is 16. X square plus 6x plus 9 plus 16 is equal to under root x square minus 2x plus 1 plus 16. Here is square. Don't take the root of both sides. Not necessary to take the root of both sides. Here is PS square is equal to PB square. We cannot find the distance here. We have to find the coordinate of point which is on x-axis. Now here x square gets cancelled. Take minus 2x on this side, it becomes 6x plus 2x is equal to 1 plus 16 is 17 and 9 plus 16 is 25. Take here minus 25 and 6x plus 2x is 8x is equal to 17 minus 25 means right 25 minus 17 is minus 8 and therefore x is equal to minus 8 upon 8. 8 ones are 8 is x is equal to minus 1. That means the value or coordinate of x is minus 1 and coordinate of y is 0 is already given and therefore the coordinate of point required answer the coordinate of the point on x-axis, the coordinate of the point which is lies on x-axis which is equidistant from A and B. Which is equidistant from A minus 3 4 and B 1 minus 4 are minus 1 0. This is value of x coordinate is minus 1. Minus 1 0 is required coordinates of point which is lies on x-axis. We can convert this example in y-axis also. Find the points on the y-axis. Find the points on the y-axis which is equidistance from point A and B and here let point P is 0 y. On y-axis x coordinate is 0 and y coordinate is y. And we can solve this example also similarly on this example and we can find the coordinates of point on y-axis. Okay, this is practice set 5.1. Remaining example try to solve yourself. If any problem, first try to ask your friend and then you can ask me also, and then remaining point we will take in next period.